Good morning, this is Mr. Sam, and today we're working on the review for the Chapter 3 final and the Quarter 2 final. So the first several problems you can do without a computer. Alright, but then we get down to number 6, and it says this is the worldwide internet usage from 1997 through 2007, shown in the table below. This is the number in millions of people who are using the internet. And there's the data. Now it says find the quadratic function that models worldwide internet usage in millions with x equal to the number of years after 1990. Use Desmos.com for this question. Record your function here, rounding to the nearest thousandths, 3 decimal places. And just to clear up a little misunderstanding, this is the word decimal. This is the word Desmos. They're not the same thing. Okay? Glad that we have that clear. Now let's go to Desmos.com. Right? Desmos.com. Launch the calculator. And hopefully you guys are familiar with this screen by now. We're going to put that data into Desmos. So we're going to add a table. Alright, and then we go back to our data. Okay, well it says x equal to the number of years after 1990. So 1997 would be 7 years after 1990. So we're going to start our graph with x equal to 7. And then it goes up by a year after that. Oops, not 161, but 16. And then this data here will go in the Y column, right here under Y1. That's where it'll go. Oh, I put in all my Y data, and then I realized that the columns didn't match, and then I go back over here and I see that's because the years skip around a little bit. After 2002 I go to 2005. Okay, 2005 is 15 years after 1990, so let me get rid of these guys. This should be 15. Okay, and then this should be 17 down here, and I don't need those other data points. Okay, now my two columns match. So I should be seeing these points, but with the graphing window I have right now, it's too small, right? Because my smallest Y value is 75, so I'm too low. So let me go over here and make a better graphing window. Let's see, I don't have any negative x's, so maybe I'll start at 0. My biggest x is 17, so maybe I'll go a little bit past that to 20. Alright, and then for the y-axis, I'm going to start at 70 and go up to about 1,300. That should get all of my data points in there. And there they are, those little green dots. Okay, that one down there is pretty low. So maybe I'll just make this a little bit smaller so that I don't lose it at the bottom of the screen there. Okay, that raises it up a little bit. There he is down there. Now I'm supposed to fit a quadratic model to this, and there are 2 ways I can do that. Okay, here's the first way. Put in the standard form of a quadratic equation. Okay, and it'll say, should I add the sliders? And you say yes, add all of them. And there you see the default values it gives are 1, and there's the curve has started there, the part of the parabola, but we want it to be thinner, so we're gonna maybe make a little bit bigger. Maybe we want to move it over a little bit. Okay, experiment with these, and then if you find that they don't change it enough, you can always change the parameters. You can say, okay, have B go from maybe 0, have B go from 0 to 100. And now your slider goes up all the way up to 100, and you can change it more. Okay, and this is a way that you can approximate the best fit, but this will not give you the exact best fit or best model. To get the best model, what you need to do is a regression. Okay, and you notice up here your variables are called x1 and y1. So when you do your regression, you're going to specify x1 and y1. All right, delete the sliders, because otherwise the Desmos will think you already know what A and B and C are, but you don't. That's what you're trying to figure out. Okay, instead of an equal sign here, you use a tilde. Oops, that's not a tilde. There's the tilde. It's at the top left corner of your keyboard. And then to make sure that you've got x1 and y1, just type a 1 after each x and y. Whoops. Oh, it might not work if you have the squared in there already. So you might have to take out the squared and then put it back. Okay, there we go. Now it's working. You can see we've got a really nice curve that fits very close to our points, and we've got our A, B, and C values. You can see that Desmos rounds the parameters to 2 decimal places instead of 3 decimal places as your assignment asks for, right? They say please round to the nearest thousandths, 3 decimal places, but we'll change that on the final test. You can just round to 2 decimal places. Now there are other questions that ask you to fit other functions, and you can fit other functions with regressions the same way. Your standard linear regression would look like this. Okay, there's the linear regression. All right, and down there you can see the value of the slope and the y-intercept. Suppose you want to do a power regression. There we go. Ax to the b power, and it gives you value of a and a value of b, the exponent, and there's that curve. And each one of these has a r squared value, so you can compare what's better, what's a better fit. And if you go back to the quadratic model, you can see that it's got a pretty good r squared value, 0.98. That's a strong correlation, strong positive correlation, very close to 1. All right, 0 would be no correlation. -1 would be a strong negative correlation. Okay, if you go to that power model, you see the correlation is still strong, but not quite as good as the quadratic model does. So that's some evidence to say that the quadratic model is a good fit to the data. Okay, hope that helped. Enjoy the rest of your review, and good luck. Bye.